Welcome back. So we are going to look at transformations of quadratics. Now we have dabbled a little bit in transformations with tables, which I know is not your favorite. So I'm hoping the second time around it will become a little bit easier. Now we're specifically looking at quadratics. So it says, what are the differences and similarities between the quadratic function and its transformation? So a transformation is how are we, transforming it? How are we moving it? Are we shifting it? Are we making it wider or more narrow? So these are things that we're going to talk about today. So it wants us to place the following in the correct category. So are we transforming the independent or the dependent variables? Okay, so let's go ahead and review first. Who is our independent? So our independent variable is our x, and our dependent variable is our y. Or if it's in function notation, it's going to be f of x, or g of x, or h of x. You know what I'm saying. Now we can transform a function in many different ways, but luckily what we're looking at is our primary focus is going to be on vertex form. So we learned about graphing with vertex form. So let's review vertex form. So f of x equals a times x minus h plus k. Now, if you don't necessarily memorize this formula, that's okay, as long as you know what everything means, how everything moves. So remember, in vertex form, HK is our vertex, okay? But if we're not necessarily graphing, if we're looking at how something is shifting, well, then we need to focus on, we talked about this before, is something happening inside or outside of the parentheses? So if it's inside the parentheses, it is going to be affecting our x value, our independent. So this is a horizontal shift. Now remember, anything dealing with the x is always opposite. So if it says plus 3, we're actually going to go left 3. And if it says minus 5, we're actually going to go right 5. Okay? So anything that has to do with a horizontal shift or something that affects our independent variable is always opposite. And this is so important. I'm going to go add this over here. Independent variable is x, and it's always opposite. Okay. So since I started with the vertex, my h, my horizontal shift, k, that is our y, that affects our vertical shift. So this is our y, and horizontal affects our x. All right, now let's look at A. A affects the shape of our graph, and by shape, I mean, well, there's two things. So think about a parabola. I can have a wide parabola. I can have a narrow parabola. It can face upside down. So A decides all of that. So A determines the shape or the width. Which would you prefer? I guess width, whether it's more narrow or more wide. So A affects the width and the direction of our parabola, whether it's happy or sad, whether it's smiling or frowning, so facing up or down. So the width and the direction. All right, so we're going to use all of these things, and again, I'm still going to come back to what I always like to think about, inside or outside. If it's inside the parentheses, it affects the x. If it's outside, it affects the y. So that's one of my first focus. A of x. All right, so the function a of x is f of x plus 2. So where is that transformation? Inside or outside? Inside. So it is affecting the x value. And what are my x values doing? Now remember, inside is always opposite. So since this is plus 2, it is actually going left 2 instead of right 2. So a of x affects our independent variable. It is going to take all of those x values and actually subtract 2. It's going to shift them left 2 units. All right. Now let's look at b of x. So first thing, inside or outside? Well, that 3 is outside the parentheses, so this is affecting my y values. So I'm going to take all of my original y values, and they're going to be multiplied by 3. So that is going to be a vertical stretch. A stretch because my y values are growing 3 times as fast. So it's gonna, my graph is going to, like I said, vertical stretch, so it's gonna get skinny. Because think about it, if it was half f of x, that means all my y values would be cut in half, so they would be growing half as fast. So vertical stretch, so it's outside, so it is going to be affecting my dependent variable, affecting our y's. All right, so c of x, let's look at this one. F of x minus 4. So again, inside or outside? That minus 4 is outside the parentheses. So since it's outside, it's going to be affecting my y. More specifically, it's going to be taking that graph and going down 4. Okay, so that is, again, since it is affecting my y values, it is going to be the dependent variable who is being shifted. All right, so the next one, f of x, well, f of 1/2 x. All right, so this 1/2 is inside the parentheses, so I know it is affecting my x value, my independent. Now, how is it affecting it? Remember, anything that is inside the parentheses is opposite. So this says 1/2 times x, or x divided by 2. So really, we're going to be multiplying the x values by 2. So we're affecting it horizontally. So let's say our x value was originally 1. Instead of dividing by 2, we're going to be multiplying. So 1, it goes to 2. 2 would go to 4. So it is going to be a horizontal stretch. For something like this, in my mind, these are the most can be the most confusing, so I actually prefer to use a table when I have a transformation like this. All right, so let's look at a few examples. All right, so we are given 3 functions to begin with: f of x, g of x, and h of x. Now, let f of x equal x squared plus 1. Okay. So f of x is going to be our original function, or our original graph. So I'm going to call f of x the OG for the original graph. Because we're going to transform these using a table and graphically. Okay? And sometimes I might do one before the other just because I think one's easier than the other, but it doesn't matter. We have to know how to do both. All right, so our OG, our original graph, x and f of x. So we do not have our y values, however, they did give us specific input values. So let's use those. So if it wants when x is -2, let's plug it in. -2 squared, -2 times -2 is 4, 4 plus 1 is 5. -1 squared, -1 times -1 is 1, 1 plus 1 is 2. 0 squared, 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. And 2 squared, 4, plus 1 is 5. All right, so we notice how we have a nice little pattern going on for our outputs. So let's go ahead and graph. So -2, 5, 1, 2, 3, 4, 5. -1, 2, 0, 1. And I'm just going to flip because I am symmetrical to the y-axis. All right. Again, when you're doing these, I don't expect perfection. However, do try to make them look more like a U than a V. Okay? So they should not look like a V at all. That is an absolute function. It is something completely different. Okay. So I think most of you have an easy time transforming graphically. F of x plus 3. So the plus 3, inside or outside? Outside. So since it's outside, it's affecting the y. So it's just going to make me go up 3. So graphically, that's really easy because I can just take my points that I already have and just shift them up 1, 2, 3. 1, 2, 3. 1, 2, 3. So I have the, whoa, that didn't work. I have the left side of my parabola, and I'm going to reflect to get the right side of my parabola. So I'm just reflecting my points, and boom. This is g of x. Oh, whenever you are graphing more than one function or equation on a line, make sure that you label each of your graphs. Now mine are color coded, so that helps as well, but still we should always label. Okay, so to me, graphing for this one is a little easier. However, we still need to get our practice transforming the table. So listen here, you smarty pants. I understand we have points. We could just plug in those points. You are correct. However, what if we didn't have a graph and they just wanted us to transform the table? Two things I want you to think about. So g of x is f of x plus 3. So who's being affected? The x's or the y's? Well, it's outside, so the y's are being affected. Is anything going on inside in the parentheses? No. So all of my x values are going to remain the same. So I don't have to do any transforming to those. I just keep them. -2, -1, 0, 1, 2. Perfect. All right, and now again, what are we doing to all of our y values? Just adding 3. So 5 plus 3, 8. 2 plus 3, 5. 1 plus 3, 4, 5, and 8. So break it down as much as you can. First, who are we transforming? Who are we changing? The x's or the y's? If we're not changing one of them, awesome. Fill in those values and keep that. If not, well, then you might have to change both. That could totally happen. So now let's look at h of x. So h of x is f of 3x. All right, so inside or outside? Inside. Now, what do we know about inside the parentheses? It's always opposite. So right now, this is telling me, what am I doing to all my x values? I'm multiplying by 3. But we're not. We have to do the opposite. So we are going to divide by 3. So I'm going to divide all my x values by 3. So x values are changing. Is anything going on outside the parentheses? No, siree. So go ahead and fill in your y values. So am I filling in 85458? No. Remember, it's a transformation of f of x, so make sure you go back to your original. So we take our original f of x values, our original y's, and we're going to plug those in. 5, 2, 1, 2, and 5. And now we are going to change our x values. So they all have to be divided by 3. So -2, does that divide nicely? No. So I'm literally just going to leave it -2/3. -1 divided by 3. 0 divided by, oh, well, that's 0. That's easy. 1/3 and 2/3. So let's see, how does that affect our original graph? Well, we now have new points. So this is why I didn't want to do this one just graphically. I wanted to look at it in a table first. All right, so here's all my green, my h of x. So -2/3, 5. Look at this point. We're bringing it way in here. And then -1/3, 2. So I'm shifting that point in as well. Notice 0, 1 did not change. Oh, wow, that got skinny. Okay, so now let's do the other side. 1/3, 2. So again, that came in. This one came in. and boom. I know it's kind of hard to make this one not look like a V because it's so skinny. So this actually turned into a horizontal shrink. We took each side and we shrunk it. We came in. So it was a horizontal shrink. Is that key? Do you have to know that? No, but I mean, if you want to kind of understand what's happening here, again, because the opposite is happening from what we're used to. So we are not multiplying, we are dividing by 3. So it is a horizontal shrink because horizontally our graph went in. You know what I'm saying? Okay. So I need to label my little graph h of x. I'll tuck that in over there. So we have transformed our original function f of x using tables and graphically. Okay, so I have 3 more examples. If you'd like to pause the video at any point and try these on your own, I think that's awesome. If not, don't worry about it. Hey, look, we kept our f of x the same, x squared plus 1. So I'll be able to use those again. We're just doing some more transformations. So you can graph first, you can do a table first. It's up to you. So if you'd like to pause the video, go right ahead. Okay, so f of x, again, that is my OG, my original graph. So I'm going to keep those 5, 2, 1, 2, 5. All right. So g of x is 1/2 f of x. Okay, so that is on the outside, so it is affecting my y's. So I'm going to be multiplying all of my y values by 1/2. Is there anything going on inside the parentheses? No, there is not. So my x values are not being changed at all, so I'm going to keep my x values. So I'm just going to write all those down. Let me go ahead and separate my 2 tables. So we're keeping our x values, -2, -1, 0, 1, and 2. And now we are going to affect the y values. We're going to transform the y values. So I'm going to take all those y values and multiply by 1/2. So 5 halves, 2 halves. 2 halves is equal to 1. If you want to go directly to 1, you can. I'm just showing my work since it's the notes. So 1 divided by 2, 1/2. Again, 2 halves gives us 1, and 5 halves is 5 halves. Or you can think about 5 divided by 2, so 2.5. So let's go ahead. Oop, I need to graph my original graph first. So -2, 5, -1, 2, reflect. Whoa. All right, and there is my original function, f of x. All right, so now we are going to plot g of x. So none of my x values changed. So I'm still starting with -2, except I'm only going up 2.5. So 5 halves, so 2.5. And then -1, 1. And 0, 1/2. 1, 1. And 2, 2.5. So look how our graph got nice and wide there. Uh-oh. Okay, I give up. Close enough. Okay, so this is our g of x function. So this one was vertically shrunk. It got wider. So that is what we call I'm calling it a vertical, darn it, I'm calling it a vertical shrink because it affected my y, which is a vertical movement. So this is what we call a vertical shrink. Okay, now let's look at h of x. So inside or outside? Inside. So what are we doing to those x values? I am going, instead of left 2, because it's always opposite, we are going right 2. So this is going to be a nice easy one to graph. Now going back to our original, so going back to f of x, so I'm going to take each point and just move it right 2. So go right 2, take this point, right 2, right 2. Oh, I need to move over. Take this point, right 2, and this one right 2. So notice our axis of symmetry has changed for this graph as well, because the original axis of symmetry was the y-axis, which is technically x equals 0. Now our axis of symmetry cuts through where x equals 2. So x equals 2 is our axis of symmetry for this one. Now if they asked you to transform the table, again, inside the parentheses, so nothing outside of the parentheses is changing, meaning my y's, they stay the same. So I'm going to take those 5, 2, 1, 2, 5 and leave them all the same. And all of my x values, instead of subtracting 2, I'm going to the opposite, and I'm going to add 2. So negative 2 plus 2, 0. Negative 1 plus 2, 1. 0 plus 2, 2. 1 and 2 is 3. 2 and 2 is 4. So did that work? So 0, 5, yes. 1, 2, perfect. 2, 1. 3, 2, and 4, 5. Fantastic. So we have successfully transformed graphs, and we have transformed tables. So I want you guys to try a few on your own. Now notice all of our examples, we either only change the x or we only change the y. You could potentially do both. That's okay within the same transformation. Just make sure whatever you need to do the x, just do to your x values, and whenever you need to do your y's, just do to the y values. All right, good luck. Let me know if you have any questions.